Okay, let's begin with just reading the question properly first of all. We have got the idea that barium combines with oxygen, chlorine and nitrogen to form ionic compounds. Barium oxide, we're given the formula and we are told, we don't even have to work that one out, that it is a giant ionic lattice structure. So we should use that information in the rest of the question. Right, so first of all we've got to state what is meant by the term ionic bonding. This is standard answer. We need the electrostatic attraction, need that word there, between the oppositely charged ions. We're also allowed to just say between positive and negative ions. Now, part 2, dot and cross diagram to show the bonding in the barium oxide. If we hadn't already been given it, we should be thinking ionic, we should be thinking this style of dot and cross diagram. So given that we know that we've got ionic, then we've got the barium over here. It's the metal, it's got no electrons in its outer shell and it's a group 2, so it's 2+ ion. And the oxygen, nice and straightforward, just picking up 2 electrons from the barium to form that. Dots and crosses can be the other way around. Make sure you've got the right charges on both of those there. So taking a look at part 3 then. Part 3 is the calculation that we need to do. So we will be calculating the number of barium ions. So we're looking for the number here and we are given a mass of barium oxide. So we will start this with, obviously, as we do with everything, we're going to work out the number of moles, which is mass over the mR, which is 1.5 over 153.3 if we add up barium and oxygen. And that gives us 9.78 times 10 to the minus 3 moles. Now remember to annotate everything that you are doing here. We then come to number. So the number is the Avogadro number times the number of moles. So it equals that number above times by 6.02 times 10 to the 23. And that gives us a final answer of 5.89 times 10 to the 21. Just check 3 significant figures in your answer there.